Hey folks, welcome to my second video. This is a video that's going to be doing similar things to what we've just been doing in terms of identifying numbers of protons, neutrons, and electrons using the periodic table. This particular one I am going to be talking about isotopes. Isotopes. You're going to do probably a little bit of reading about these, but definitely trying to understand what the heck the isotopes are. So, what is an isotope? An isotope is when you have atoms of the same element, but they have different numbers of neutrons. Different than normal, or maybe the same as normal, but you have different atoms that have different ones. And I'm going to use one of the more common elements that we tend to start talking about as being isotopes, and that is the element carbon. Carbon, generally, if you look at it on the periodic table, it's got an atomic number equal to 6, and it has an atomic mass equal to, roughly, if we round it to the nearest whole number, 12. Using that information, we would normally say, hey, the number of protons, the number of neutrons, and the number of electrons. We would say that the number of protons is 6, and if it's a neutral atom of carbon, it would have 6 electrons. To get the number of neutrons, we would take the atomic mass, 12, minus 6, that would give us 6 neutrons. And that's your normal, most common form, or most common isotope of carbon. But carbon also comes in a different form. There is carbon, it's possible to have carbon that has the atomic number equal to 6 because it's carbon and atomic number defines it. But there are carbon atoms that have an atomic mass that are not equal to 12, that you wouldn't find on the periodic table, but they do exist. For example, carbon can exist where it has an atomic mass of 14. Notice that is different than what you find on the periodic table, but it is possible to have that isotope of carbon. It's carbon that weighs different, and it weighs differently because if you look at this, the number of protons, the number of neutrons, and the number of electrons, the protons, they're 6 because the atomic number is always equal to the number of protons. The number of electrons, we're going to again assume it's neutral, would be 6, so the electrons and protons would have the same number. But now for the number of neutrons, remember it's the atomic mass, 14, minus the number of protons, 6. There would be 8 neutrons. And so it is possible to have carbon, and it's usually likely that you can have carbon that has 6 neutrons. That's the most common form. That's why on the periodic table they give the mass as 12. But it is also possible to have carbon that has 8 neutrons that would give it a mass of 14. And so when you have isotopes, that's what's going on. So let me go to a new page. So when you have isotopes, what that means is that you have atoms of the same element with different numbers of neutrons, which means different masses. And they are different from what you would normally expect to find using the periodic table. So let's look at another example of this. Let's say we were dealing with, let's say, a form of nitrogen. I'm going to go to a new page here. So let's say we had nitrogen. Nitrogen normally is found, it's got an atomic number equal to 7 and an atomic mass equal to 14. For that normal, most expected isotope of nitrogen, it would have 7 protons, it would have 7 electrons, and for the number of neutrons, it would be 14 minus 7, or 7 neutrons. On the other hand, what if you had nitrogen, and it is possible to have nitrogen in different isotopes. Let's say you had nitrogen, and let's say this nitrogen, its atomic mass, again, it'll be different than the normal expected mass of nitrogen. Let's say you had nitrogen that had an atomic mass of 15 instead of 14. What would that mean? Well, it would mean that the number of protons, it's still 7 because the atomic number didn't change. We're still dealing with nitrogen. Number of electrons, it's still neutral, so that would still be 7. But my neutrons are now going to be 15 minus 7, not 14 minus 7, and that's going to give us 8 neutrons. And so when you have isotopes, that's what's going on. You have different numbers of neutrons than what's expected. Now, what does this mean in terms of the types of problems that you've seen in class, the little tables that you have to fill in? Well, let me pull this up and kind of show you. You'll remember those tables usually have the element, they've got the atomic number, the atomic mass, and then there's a column for protons, neutrons, and electrons. And so we have these nice columns, and you usually have to fill in information. Now, if, and this is important distinction here, if in this chart that you're going to have to fill in missing information, if I do not give you the number of neutrons and the atomic mass, if I don't give you either of those, you're simply going to use the most common form of the element. You're going to look at the periodic table and you're going to find what goes in there. So an example might be if I gave you this column across, and let's say all I told you was that you had, let's say, atomic number 20, and you wanted to fill that in. You would know element 20 is calcium. You know that the atomic number is the number of protons, that's 20, and that's equal to the number of electrons, and you'd have that. But if I didn't give you the mass or the number of neutrons, all you can do, the only thing you know how to do at this point, is to look at the periodic table, find the mass on the periodic table, and round it to the nearest whole number, which would be 40. And then to find the neutrons, it'd be 40 minus 20 to give you 20 neutrons. On the other hand, and here's a new situation, this is where it's going to get a little tricky when you see this all combined. If I were to give you, let's say, an example where I told you you had element, the number of protons being 14, and let's say I told you that the atomic mass of that particular one, what if I told you that was 30? Well, if you now had to fill this in, notice I have now given you one of these two pieces of information. I've given you the atomic mass. So now we have to fill in this chart for this element that I've given you 14 and 30 for. So element 14, you're going to look it up. Its atomic number would be 14. That element would be silicon. To figure out the number of neutrons, you're going to do 30 minus 14, and that's going to be 16. And we're going to assume it's neutral, so it's going to have 14 electrons. Now notice this one, silicon. If you look at the periodic table and you look at the mass for silicon, you're going to see on your periodic table it doesn't say 30. On the periodic table, it will tell you that the mass should be 28. That's because by me giving this to you in the initial problem, I'm giving you an isotope that's different than normal. And you want to use what I give you there to find the number of neutrons. I hope that made sense. You could also have a problem where I give you the number of neutrons and maybe that's not the normal number. Let me go back to an example that we used earlier. Let's say I told you we were dealing with the element oxygen, and I told you that for this oxygen, maybe the number of neutrons that we're going to have, I guess we didn't use this one before, but let's say I told you that the number of neutrons was 18, and that's all I gave you in the whole problem. Well, you would look for oxygen. Its atomic number is 8. You would say it's got 8 protons. We're going to assume it's neutral, so it's got 8 electrons. And now we have to figure out the atomic mass. Now remember, the atomic mass is the number of protons plus neutrons. So if I take 8 plus 18, I'm going to get an atomic mass of 20. Is that right? Did I do that right? Oh, I shouldn't have given you 8 there. I apologize. I should have given you 10 there. My bad. I'm going to take the 8 plus the 10 to give me 18. If I look at the periodic table, the atomic mass of oxygen is not 18, it's 16. But you want to use 18 because by me giving you this value here in the initial problem, I'm giving you an isotope that's different than normal. It's going to give you a different mass than normal. So the trick here, the trick is for these, when I give you one of these charts, if I give you either the mass or the number of neutrons in the table, use what I give you to find the other one. If I don't give you either of them, then just use the periodic table and use the most common isotope. So that's one of the first things in one of those tables you want to look for, are any of the situations where I give you the number of neutrons or I give you the mass, and you have to kind of mark those to know, hey, I have to use that. It's going to be an isotope. It's going to be different than the normal. If I don't give you either, then just use the periodic table to find the mass, which then you can use to find the number of neutrons. I hope this was clear. I hope it made sense. I'll give you some sample problems for isotopes, and they will all be isotopes different than normal, so that hopefully it'll start to become clear. And then you are going to see a handout that has everything all mixed, and that's where you got to watch out. That's where literally when I get one of those charts to fill in, the first thing I do before I even try any of the problems is I try to identify the ones that have the mass or the neutrons given to me, so that I know that those, I try to do those first, knowing that those will be different isotopes. I hope this video helped, and good luck with this, and I will see you on Wednesday.